All right, so this is section 3.4, multiplication of whole numbers. In the grade 3 Common Core standards, this is kind of just a summary of what you'll find in the grade 3 Common Core standards, but students are expected to be developing an understanding of the meanings of multiplication and division through activities and problems involving equal sized groups. What that means is like, since we can think of multiplication as repeated addition, the groups have to be equal sizes. So one of the examples we're going to look at is like a little girl brings home 3 bags of goldfish, and each of the bags has 8 goldfish in them. All right, so equal size groups. And students should be able to use increasingly sophisticated strategies based on properties of operations, the operations being multiplication, division, addition, subtraction, to solve multiplication and division problems. All right, so that's things like that commutative property, the identity property, the associative property. All right, so the two main models of multiplication, I'm sure you can do research and find even more models, but these are the two that are emphasized the most, are the repeated addition model and the rectangular array and area models. Repeated addition is like the precursor to multiplication. So you start off and say like, you have 3 groups of 8, and we know that that's the same thing as 3 times 8. And then you get, the groups get increasingly larger in size. So 3 groups of 25, 3 groups of 57. And then you want to like demonstrate to students like it doesn't make sense for us to sit here and count, 1, 2, 3, 4. And so that's how you motivate this new operation of multiplication. And then the rectangular array, you can think of that as like those big boxes of eggs, those big cartons of eggs you get at the store, that have like, I don't know how many is in there, like 6 by 8 or something like that. And they use those to motivate a different method of multiplication, or a different way of viewing multiplication. Yeah.
I just did the worksheets for my 3rd grade class that I sent on Monday, and they were doing this, and then they were doing the sub partial addition.
Yeah. Right. So repeated addition, it's described as being the foundation for understanding multiplication. So, like I said, you can understand something like 3 groups of 8 as 8 plus 8 plus 8, and then we're motivating that to learn multiplication. All right, so here's my example for the repeated addition model. Jessie used 3 bags to bring home the goldfish that she won at the carnival. She put 8 goldfish in each bag. How many goldfish did she win? And how many goldfish are going to be alive by the time she gets home? Not all of them, not 100%. All right, so she's got 3 bags. In each bag, she's put 8 goldfish. All right, so I drew little bags here. Yeah, I was having like way too much fun doing this in my office yesterday. And then I forgot I had the door unlocked, and someone came in and that gave me a heart attack. And they're like probably thinking, why are you in here drawing bags of goldfish?
So you drew those fish?
No, I grabbed the clip art of the fish. I drew the bags though.
That's still pretty cool.
Yeah. All right, so our repeated addition model, we would probably start with 8, right, and count on. That was one of our addition strategies from last week. We would start with 8, and then 9, 10, 11, 12, and then count all the way to 24. 8 plus 8 plus 8 is 24. All right, but of course we know this is also the same thing as 8 times 3. All right, so the repeated addition model It's one of the foundations of understanding multiplication. And one thing that I wanted to emphasize here is that in order for this to work, the groups have to be equal in size. Right? You're not going to have one bag with 6 goldfish and another bag with 10 goldfish. The groups need to be equal. All right, so the second model was the rectangular array model. All right, so a rectangular array, you may have seen the word array before. That's what they call that like Excel spreadsheet. It's called an array. But it's really just an arrangement of rows and columns. So you can use a rectangular array to motivate multiplication. You can use any type of shape or any type of object that you want. In this example, I said, Daniel keeps his swimming medal collection in a display on the wall. The display has 4 rows. Each row has 5 medals. How many medals are in Daniel's collection? All right, so I made this little array. I was also reading that this is a really good way to motivate the commutative property of multiplication. You could switch the size, like instead of having 5 columns and 4 rows, you could switch it and have 5 rows and 4 columns and show students that it's in fact the same amount. It doesn't matter which one was assigned to be the columns and which one was assigned to be the rows. So this is also a good way to motivate commutative property. Or we'll say good way to demonstrate the commutative property. Now you can use anything here. I saw like a whole study was done on using the egg carton to do the rectangular array and how that's something that kids see in the grocery store or might see at home, and so something that they're familiar with, and so that's a good way to or a good example to use for students.
You could do your whole gummy bear thing too.
Mm-hmm.
So that'll get their attention.
Oh yeah.
Gummy bears.
Yeah.
I remember we done those before, like the teacher passed out gummy bears.
Yes, I remember that
Don't
too.
eat these.
Yes, I remember that too now that you say that. I was reading in the article that was written about using rectangular arrays to teach multiplication. It said that this is a good way to encourage spatial learning for kids. So spatial meaning like being able to visualize, like if you switch the rows and the columns. I know that I am not personally a spatial learner, so that it would have been difficult for me to envision like switching the rows and columns, but some kids are really strong spatially and can imagine that. And it's also that paper also noted that this is a good way for kids to learn multiplication without having to just memorize stuff. All right, so it's like a way to demonstrate and visualize instead of using rote memorization. All right, so whenever we're counting these up, the book recommends that you use skip counting here, skip counting by 5s. So you would go, let me see, I might have to erase this part, get it out of the way.
So that'd be like 5, 10.
Yes. All right, so there we go, 5, 10, 15, 20. All right, and so this is a demonstration of the expression 5 times 4. So 5 times 4 is 20. All right, so again, you can use any kind of object, any kind of shape. You could pass out, little objects to students to be able to arrange these on their desk. So this is a good way to motivate multiplication. bingo circles or whatever. Yeah, we have a bunch of those over in the office, and it's like very nostalgic to look at all that stuff. All right, so lots of properties of multiplication. Now, I would like you to be able to look at an expression and tell me, oh, this is the commutative property, or this is the associative property. But this is, I mean, really and truly, it's not the most important thing for you guys to be able to do. The most important thing is for you to be able to demonstrate the strategy. So while this is important and I want to make note of it, it's not something that I'm going to test you over. All right, so we have 6 properties of multiplication. The closure property, we saw in that, if you watch that video on subtraction, that subtraction is not a closed property. That means that if you take 2 whole numbers and subtract them, you don't necessarily get back a whole number. Like if you do 3 minus 5, that's -2, that's not a whole number, right? But the multiplication is a closed operation, so if you pick any 2 whole numbers, 5 and 4, 6 and 7, and multiply those, it's going to give you back a whole number. All right, so multiplication is closed. The commutative property, that's like the order, right? So 3 times 2 is the same as 2 times 3. We're going to go through all these individually, and I'll give you the formal definition, but I just wanted to give a brief overview. The associative is like the regrouping, right? So you can do 5 times 4 first. If you're doing something like 5 times 4 with parentheses around it times 2, you can do the 5 times 4 first, or you can regroup them and do 2 times 4 first. Identity is, what's the identity in multiplication? What gives you back the same number? 1. Yeah, anything you multiply by 1 is going to give you back that original number. What about 0? What happens when you multiply by 0?
You
Get 0. Yeah, so that's the property of 0. It just says that anytime you multiply by 0, it's going to give you back 0. And then we have the distributive property, which says that you can distribute that to each term inside of a set of parentheses. All right, so here is the closure property. This is where, like I said, if you are given 2 whole numbers and you multiply them, it's going to give you back a whole number. All right, so if A and B are whole numbers, then A times B is a unique whole number. All right, so any 2 whole numbers that you multiply, doesn't matter which 2 you choose, you can do 122 times 5,820. If you multiply those, it's going to give you back a whole number. Huh? Yes, addition is also closed. So the only one that's not closed, or the ones that are not closed, is subtraction and division. Those are not closed. And basically what I took from this for you guys is that you just want to be a little bit careful when you're writing the problems for subtraction and for division. Make sure that you're going to end up with something that's a whole number, or something that's not negative. So just be a little bit more careful. With addition and multiplication, you can just kind of throw any 2 numbers out there and it'll work. But with subtraction and division, you have to be a little bit more careful. All right, commutative property. The commutative property says it doesn't matter what order that you multiply these terms in. You can do, for example, 5 times 4 is the same thing as 4 times 5. All right, so you can switch those around. And that's kind of the same thing like we were talking about with the rectangular array. So 5 rows and 4 columns is the same as 4 rows and 5 columns. All right, so again, that rectangular array is good at demonstrating the commutative property. Do y'all remember learning these in school?
Yes.
I do too. I remember learning them like several times. But this is something that people tend to forget. All right, associative property has to do with grouping. I always thought like the way I remembered this was like the people you associate with is like your friend group. That was the way I remembered that. All right, so you can group these any way you want. We have A times B times C. If you group A and B first, that's the same thing. You're going to get the same answer if you group B and C first. So just a little example. We could do 6 times 5 times 2 is the same thing as 6. Oops. 6. Then we group the 5 and the 2 together. So those are the same thing. Right. That is the associative property.
This was on the 3.2 homework too.
Mm-hmm.
Sorry, 3.3 homework.
Yes.
Because I started it and then it got into this and I stopped. Because I got one wrong and I was
Yeah.
like, wait, maybe I'm confused. I got the associative and the commutative, some reason I got them mixed up.
Mm-hmm. All right, so associative has to do with grouping and commutative is the order.
Because the commutative can also have, like one of the commutative questions was, it was like this, but they were 6 times 5 times 2, and then it was like 2 times 5 times 6.
6, yes, I saw that one. I think I put that one on the homework too.
Yeah.
Because I thought that was,
But it was it was commutative.
yes.
Because it didn't change where the number was in the parentheses, it just changed the order. Like
Yes, that's right. That's right. Identity property says that there's a unique whole number, and that number is 1, and it has a special name. It's called the multiplicative identity. The multiplicative identity. All right, so 1 is the multiplicative identity. The additive identity, remember, was 0, because if you add 0 to anything, it just gives you back that original number. But multiplicative identity is 1. And the identity property says that for each or for every number A times 1 is just A. All right, so any whole number that you multiply by 1, 125 times 1 is just 125. And your book uses the dot for multiplication a lot. Like they almost never use the X for multiplication. So I don't know if that's just your book or if that's, a part of the Common Core is that they want you to use the dot. But
it might be, they want you to use the dot because if you use the X, then you're going to get confused with maybe a variable or something.
Mm-hmm. Yeah. I find that I do too. I prefer the X because sometimes students can overlook the dot, or maybe they think it's a decimal point or something. So I like the X, but it'll totally be determined by what type of materials that you're using in your class as to which one that you end up using.
Now, does each specific school require you to teach a different, out of these methods that we're learning, will they pretty much tell you what method you have to use in your classroom?
I want to say that, like, part of the standards are, like, they want you to include, these certain methods. So it should be standard across all schools. Yeah.
We had to do it in Education 2130 last semester, and we had to look over all the standards, and we had to make a lesson from the standards. That was like our final, and all the standards for Georgia are like
the same. Yeah. So I guess maybe the only type of schools that wouldn't fall under that umbrella are any school that doesn't receive like state funding.
That would be like Fort Stewart then.
Yeah. Yeah.
Yeah, their curriculum's really different.
And I think let me pause the video. All right. The property of 0. This is a really simple property. It just says for every number A, if you multiply by 0, it's going to give you back 0, no matter what that whole number is. And really, you see that they left off the words whole number here. That this goes for every number, but we'll use a whole number since that's what we've been talking about. 5 times 0 is 0. Alright, so very simple property, easy to identify, easy to demonstrate. Right, so if you're thinking of this as like repeated addition, this would be like if we added 5 0 times, you would have 0.
It's also with 5 plus 0. Oh wait, 5 plus 0 equals 4. So what would that be called?
That is the additive identity, 5 plus 0, yeah. All right, and then last we have the distributive property, which I'm sure you're all familiar with. It says if A, B, and C are whole numbers, then A times, and then in the parentheses we have, whoa, I have a mistake there. That's supposed to be a plus. Close one. Say it again. Yeah, you're multiplying A times B, and then A times C. Yep, that's okay. Oh, I also noticed that if they have a number outside the parentheses, now this is just your book, but if your book has a number outside of the parentheses, they do not put the multiplication symbol there. So, yes, so you're not going to see your book do something like this. Right, so, yes, they're just going to have the 2 there.
Right, and then you just distribute.
Yes. So, just be aware of that. All right, so this would be the same thing as 2 times 6 is 12, plus 2 times 2 is 4.
So on the test, are we just gonna be identifying what the properties are, what formula is being used?
That's on the homework, but I won't put this one, I won't put the properties on the test. On the test, it'll be more like demonstrate the lattice algorithm or the lattice method of multiplication.
Oh, okay.
Yeah, so on the test, you won't see these properties, but you will see them on the homework.
Now that I was doing the homework earlier for the addition and like there was the lattice.
Yeah.
I actually liked it.
I do
Like,
too.
as soon as I figured out how to do it, I was like, okay, I actually like this.
Yeah, and we're gonna do lattice today again, and it's like I think it's my favorite one. All right, so let's take a look at some examples, and I want you to take a second and look over 1 and 2. Yes, just look over 1 and 2, and
And I got them wrong.
one of them is commutative, one of them is associative. So see if you can figure out which is which. Remember, associative is like the grouping, commutative is the order.
Now it makes sense, but yesterday when I was trying to do it, I got wrong.
Yeah. Well, I always find that my presence makes the homework easier. Yeah. I don't know what it is, just my being here. It's like when I call the internet people and then my internet immediately starts working. I'm like, okay, never mind. Have a good day.
Or like when you take a pregnancy test. And then
Yeah.
I'm not pregnant, by the way.
Yeah, I'm so glad. Me neither. I thought about you though. Yeah.
So I'm gonna say number 1 is associative and number 2 is commutative.
Would y'all agree with that?
Yes.
Me too. Associative for number 1, commutative for number 2. What would you say for number 3?
Property 0.
Good. All right. What about number 4? Yep. 5 could also be thought of as distributive, but they're going to call it something different. Yes, your book or the homework is going to call this the identity property, but yes, you could also think of this as the distributive property.
Because it's 5 times 4, no matter how you.
That's right. Because 5 times 4, if you're multiplying that by 1, it's always going to give you back 5 times 4.
But I like how they did that, because it's kind of tricky.
Mm-hmm. Because it kind of looks like you just distributed the 1.
Right.
All right. Here's where we're going to get into the algorithms. using base 10 blocks to develop the standard algorithm. Now, when I first was thinking about using base 10 blocks to demonstrate multiplication, I was kind of struggling with imagining what that would look like, but I have two examples of how you can do this, and I think that it might be a good visualization for students. It's not something that I would use like consistently, like every time I multiply, but it could be something good for students to visualize. Partial products. That method is one that I struggled with the way that your textbook does it, but whenever I looked up a different method of doing it, I found that the partial products algorithm was very helpful. And then I think lattice multiplication is probably my favorite.
So let's talk about using base 10 blocks to develop our standard multiplication algorithm. We're going to work with the problem 4 times 12. All right, so if you were using base 10 blocks to demonstrate multiplication here, you might think of this as adding up 4 groups of 12. All right, so we're going to take 4 groups of 12 and we're going to combine them into one big group. So combine all the 10s, all the 1s. And then we're going to count them up. We know we have 4 10s, so that's 40. And then we have 8 1s, so that's 48. So 4 times 12 is 48. Now let's look at our concrete model. 4 times 12, we might write that with the 12 on the top. The way that we would do this is we would say 2 times 4 is 8. 4 times 1 is 4. Alright, so that's our concrete model that we're probably all the most comfortable and familiar with. Alright, so I want to show you this video here that'll play. There we go.
Can be thought of as one number telling how much to take.
Alright, so she goes on to do a partial products algorithm here to demonstrate multiplication. But what I want to show you is that you could now get students to count up this total just by saying, okay, I have 2 of my 100 blocks because those are orange, so I know that those are 2 100s. Count up all the 10s. You have 1, 2, 3 10s here. 1, 2, 3, 4, 5, 6, 7, 8. So 8 10s. And then 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 1s. And then you could have them add that up. 2 100s plus 8 10s plus 12 1s to get the total. Alright, so this is another way that you can use base 10 blocks using that kind of rectangular array idea to develop our standard algorithm. Next, we have the partial products algorithm. Alright, so the partial products algorithm is a little bit complicated the first time you see it, but the concept here is that you are going to be multiplying each digit of a number in turn with each digit of another number where each digit maintains its place value. Alright, so for example, the 2 in 23 is actually 20, so it's 2 10s. This is kind of an expanded form of our standard algorithm, but it allows students to break down multi-digit numbers into simpler terms that they may already know the multiplication facts for. Alright, so I'm going to start with 23, and remember what I'm supposed to be doing here is I'm supposed to multiply each digit of the number 23 in turn with each digit of the number 14. And then I'm going to turn the tables and I'm going to take the number 14 and I'm going to multiply each digit of the number 14 with each digit of the number 23. All right, so here we go. We're going to start with 2 times 10. Excuse me, 2 times 1, which is really 20 times 10. All right, 20 times 10 is 200. Then we're taking 2 times 4. It's really 20 times 4 is 80. All right, then we're turning the tables. We're starting with the 14 here. We have not done 10 times 3 yet, so we're going to do that. 10 times 3 is 30. All right, then the last thing we haven't done yet, we've already done 1 times 2. We've done 1 times 3. We've done 4 times 2. So now we got to do 4 times 3 is 12. So what we did is we started with 2 times 10. So we started here. All right, then we said 2 times 4. Then we did 1 times 3. Then lastly we did 4 times 3. So we're multiplying every possible combination. All right, then we're going to add those up. 200 plus 80 plus 3 plus 12 gives us our total. Or excuse me, I think I said 3. I meant to say 30. 200 plus 80 plus 30 plus 12 gives you 322, which is the product. All right, so we're breaking this down into multiplication facts that your students probably have memorized to try to make this into a simpler problem. All right, now let's look at lattice multiplication, sometimes called Chinese multiplication. It is a written method of multiplying numbers, and the advantage of lattice multiplication is that it teaches students a strategy for multiplication rather than rote memorization to find the answers. All right, so you're teaching students a strategy for multiplying. That way they can go on to use that strategy for many, many different numbers. All right, so you're going to start by drawing a box, and on the outsides of that box, let me switch to my laser pointer here. On the outside of that box, up here on the top, you're going to put one of your factors. So whenever you're talking about a multiplication problem, each piece is called a factor. Remember when we were talking about addition, each piece was called an addend. With subtraction, they were called the subtrahend and the minuend. And here with multiplication, they're called factors. So you're taking each of your factors, 23 and 14, and you're going to write them around this box. So take your first number, put it up here on the top. And take your second factor, draw it on the side. So 1, 4. All right, now you're going to draw a diagonal line rising from left to right in each one of the boxes. So you can see I've done that here. And now I'm going to start multiplying. I'm going to have much smaller, much more manageable multiplication problems here. I'm going to start with, let me switch back. Okay, I'm going to start here. 3 times 1 is 3. All right, so I'm putting 0, 3. Or I guess you could just leave the 0 off. You don't have to put anything there. But 3 times 1 is 3. All right, so I'm writing 0, 3. 2 times 1 is 2, so I'm writing 0, 2. All right, now I'm moving down here. 3 times 4 is 12, so I'm going to write 1 and 2 for 12. Lastly, 2 times 4 is 8, so I'm going to write 0, 8. All right, now what I have created here, each of these little diagonals represents a place value. So each of the diagonals represents a place value. Down here at the bottom, this is the ones. The middle is the tens. This is the 100s, and this is the thousands. All right, so let's start adding. 2 is the only digit that we have in the ones place, so that just drops down. In the tens place, we have 3 plus 1 plus 8 is 12. Now, that we're over 100 now. 10 12 tens would be 120, so we need to move that 1 over into the hundreds column. All right, so that 1 is going to float up to the top. We're going to carry the 1. All right, so 1 plus 2 is 3. And we have a 0 in our thousands place, so we don't need to worry about bringing that down. All right, so now we have 322, which is our answer. All right, so I think this is a really fun way to multiply. And it's a good strategy for teaching students how to multiply large numbers together pretty quickly. All right, so last thing we're going to talk about is some mental computation and estimation with multiplication. So the methods that we have for mental computation of multiplication problems, we have front-end multiplying and then also using compatible numbers. All right, so when multiplying mentally, people generally like to start with the larger quantities first. You're going to start and you're going to take 64 and you're going to break that down into 60 plus 4. Now, some students noted that they preferred to write it in the following way. Let me just show you. So if you don't like the way that this is written, I've broken 64 down into 60 plus 4. You could also just break this down into 2 separate pieces and do 60 times 5 and then 4 times 5. Alright, so that is a totally acceptable way to do front-end multiplication as well. Alright, so I've broken 64 down into 60 plus 4, and now I'm going to multiply. 60 times 5 is 300. 4 times 5 is 20. Left off a 0 there. There we go. Alright, so adding up those two values, we have 30 plus 20 gives us 320, which is our answer. Now, compatible numbers. We're using this term loosely here. So compatible numbers are numbers that are easy for students to work with. A compatible number is defined as anything that ends in a 0 or a 5. So, for example, if you have a number like, let's say 87, then, or let's make it into a whole problem, 87 times 3. Now, if we are doing this using one of these mental multiplication methods, we might break this down into 80 plus 7. But your book considers 85 to be a compatible number, so they might break this down into 85 plus 2. Alright, so they might do 85 times 3 and then 2 times 3. Alright, so that is one way you could do it with compatible numbers. If you would prefer to break 87 down into 80 times 3 plus 7 times 3, that is totally fine. That is how I would probably feel most comfortable. That is the numbers that I would feel are most compatible. But just know that your book considers anything that ends in a 0 or a 5 to be a compatible number. Alright, so let's look at an example. Suppose that we have this long string of multiplication, 2 times 9 times 5 times 20 times 5. Alright, so when we are using compatible numbers, we want to group together the numbers that are going to give us these nice numbers to work with. So for example, we can group together 2 and 5. 2 times 5 is 10. We could also group 20 and 5 because 20 times 5 is 100. Alright, so we can regroup this. This is the commutative property of multiplication. You can see I've regrouped this into 9 times 2 times 5 times 20 times 5. Alright, so we're really using the commutative property and the associative property here because I just regrouped some stuff as well. Alright, so I know that 2 times 5 is 10. I know that 20 times 5 is 100. That gives me 9 times 10 times 100, 9 times 10 is 90. 90 times 100 would be 9,000. Left off a 0 there as well. Okay. All right, and then lastly, we have estimation. It's important to talk to students about the value of estimation, that this can provide you with a way to make sure that your values are reasonable, make sure if you solve the problem, make sure that you are getting a reasonable value, your book specifically says it helps you determine whether an answer is reasonable or not. This is especially useful when the computation is done on a calculator. All right, so determining whether your calculator has given you a reasonable answer. This could also be used in, a person's day-to-day life. Estimation, we use estimation all the time. When you're calculating tips, if you're at a restaurant, or figuring out how much you spent in a day, we all probably use estimation pretty frequently without thinking about it. All right, so we're going to start with front-end estimation. It looks pretty similar to what we saw with front-end multiplication. All right, so we're going to take 524 and break that down. We're going to say 524 is approximately 520. We can break that down into 500 plus 20, and then multiply by 8. Again, if you would prefer to write it as 500 times 8, and then 20 times 8, and then add those up, that's totally fine. 500 times 8 is 4,000. 20 times 8 is 160. So add those up, and that tells us that 524 times 8 is approximately 4,160. All right, so that is front-end estimation. Now with compatible numbers, remember they are considering a compatible number to be anything that ends in a 0 or a 5. So in your book, they might take 524 and say, instead of saying that's approximately 520, they might say that's approximately 525. And then you could have your students break this down into 500 times 8, and then 25 times 8. If they have worked with money in the past, then they might be comfortable doing something like 25 times 8 from counting up quarters. But to me, I feel like the 5 could potentially throw some students off. So compatible numbers are defined to be anything that ends in a 0 or a 5, but you might want to think carefully about what you're considering a compatible number in your classroom. All right, so they break that down into 500 plus 25, multiplying that times 8. 500 times 8 is 4,000. 25 times 8 is 200. You can think of that as being, if you took 4 quarters, that's $1. If you had 8 quarters, that's $2. All right, so estimation here with compatible numbers tells us that 524 times 8 is approximately 4,200. All right, so that's everything for the multiplication of whole numbers section. If you have any questions, please let me know.